In this segment, we'll show the proper techniques for floor routing and heat welding. When routing your sheets to achieve your kerf for your cove base, you will route the back side of the sheet using a plunge router. It's important to remember that when you're routing your sheet for a cove base, the sheet needs to be on a flat, stable area such that you don't have any undulations in the sheet as you route. The plunge router will follow any substrate undulation, so be sure that you're on a good flat surface or on a pallet of material with plenty of material underneath to support the sheet. Your plunge router will need to be set at a depth of 1/8 of an inch to route halfway through the material in order that the material bend at the cove. Prior to beginning your heat welding, you'll want to hand route both edges of each sheet to be welded. You can use your hook blade or your straight blade for this.
After you have a clean cut, you're ready to groove your seams and get it prepared for a weld. Make sure you have a clean cut. You could take a piece of material or a straight edge and put it underneath one of the sheets. You want to take a hook knife and just get a good, probably about an 1/8 inch wide bevel. Going down your sheet. One thing that's important is you want to leave just a slight little bit at the bottom, maybe 10%, that doesn't get cut, so these two pieces can melt together at the bottom once they're welded. I do that on both sides so that when it's welded, it's 100% whole at the bottom. You want to cut it probably 90% of the way through, ideally. You just want to make sure that you get a good straight cut and it's not wavy. Any types of waves is going to make your seam kind of look wavy. It'll show any mess ups or fluctuations that you do with the knife. So you just want to keep it as straight as you possibly can. And it's definitely something that just takes some time. I'll get my one side beveled. I'll take it out and do the other side. Typically, after your route is finished or your groove, you want it to show about a 1/4 inch of gap, maybe a little more. It's shaped like a V, just like our V rod. It'll melt right down inside of there. Here I'll demonstrate the routing technique with an electric groover. This is a Leicester electric groover and is the most popular for this application. So you're going to line up your arrows along with your seam that's already cut. Make sure the arrow in the front along with the arrow in the back are both aligning. And you're going to push down after you start the motor and just get very even pressure throughout. With the correct blade and setting on the groover, you create a perfect groove for the weld to drop into. Notice there's still a small sliver, about 10% left on the bottom, where the weld can meet and weld at. If you're using the electric groover on an uneven substrate or a retrofit project, it is a good idea to use a 1/2 inch piece of plywood underneath the seams as you groove. This will prevent your electric groover from hitting a low spot and bouncing out and damaging your sheet.
Temperature of the heat welder is probably the most important facet of heat welding. You want to be sure that the temperature is not too hot such that you're burning the weld in the material. Also want to be sure that the temperature is not too low such that you're not getting an adequate melt. The most effective way to test your welder to be sure that you're at the correct temperature is by employing something we call the burn test. Turn your welder to a temperature of 6. Hold the nozzle 1 inch away from a scrap piece of EcoGrip material for about 10 seconds. If the material burns or appears charred, your heat welder is turned up too high. Adjust down to a temperature of 4 and repeat the step again. Your goal here is that the material be completely melted following your test, but not black and charred.
All right, I'm gonna do a quick burn test here. I'm gonna get my welder probably 3/4 inch away from the material and hold it for a quick 10 count. Just to make sure melting at the right temperature. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see here that the material's a little bit charred. It's probably gonna be a little too hot. It's gonna leave black residue and char marks on your weld. So you're probably gonna wanna cool it down. Probably a full notch or 2 full notches. Let it sit for 4 or 5 minutes till it adjusts temperature and try again. All right, I have my temperature adjusted. I'm gonna try the burn test one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what you want right there. It's melted on the surface, but it's not turning black, and it's not getting crusty. It's staying soft. Your first step welding is just to make sure that this cut is good and make sure that your floor is level on both sides and is all the way down to the floor. Any fluctuation where one side is 1/8 inch higher than the other or 1/4 inch is going to make the weld look a little suspicious. When you start a weld, you usually want to get the tip a little bit warm. Give it a little bit of a warm up. You just want to take your time and be very consistent. And keep your welding tip very level so you don't make marks on either side of the sheet. You just keep a very consistent speed. If you slow down just a little bit too much, you'll burn the sheet. If you try to speed up, you'll leave cracks in the side of the weld where it's actually not going all the way through. If you look closely, you'll see there's little sides on each, there's little melt marks on each side of the weld. That's showing that it's going all the way through, and there's a little bit of extra weld coming up on the sides. That's good. I'm also pushing through with my left hand. I'm pushing the weld through just to make sure it doesn't get stopped up in there. It doesn't stretch out and leave a crack. I'm not really putting a lot of pressure down. I'm probably only putting 5 pounds of pressure. It's just the heat is kind of holding me down in there. Once you get a weld started, it tries to stay deep. You can see right there where I slowed down a little bit. Kind of started to stretch. Your next step is going to be to shave the welds. Try to get it as smooth as possible with your floor finish. And usually you want to give it just a couple minutes before you shave it, just to where it's kind of room temperature, maybe a little warmer. If you try to shave it when it's too hot, you can't get it smooth like you would like. So you just give it a minute, try to suck the heat out of it. If I start over here, you just take your quarter moon knife, and you just get a feel for how much pressure it takes to stay in there, and it's going to want to just go right along like that. As long as it's not too sharp, it shouldn't damage your floor on the sides. If it's been sharpened very recently or not sharpened correctly, it can dig out your sides and ruin your whole weld, so just be careful that you're going slow with your flat knife and getting a feel for it. And you really don't even need to touch the metal. You're really just blowing hot air on your seam just to kind of darken it up and giving it color. You don't want it to touch much at all. I'm going to go ahead and turn up my welder and do it the other way. As you can see here where it's been struck and here where it's still raw. It just kind of darkens it up, gives it a little bit of a shininess, just kind of seals it. One thing about doing the strikes is it's best to do it all at once so it all looks uniform. I like to shave all these off in one area or the whole job and come back and turn my welder up to 9 with the straight edge and just strike all the seams. That way they all look the same. Different welders, you know, all trying to strike their own seams, they look a little bit different. You just want to keep it as uniform and professional as possible. So I think I probably got the right heat adjustment. I'm just going to strike the rest here. Yeah, a little hotter. It's clear to see a difference here and here. When you're striking or welding, you want to make sure that your welding tip stays very clean. You can use a wire brush. You can use a small piece of weld. And you can just kind of make sure you don't have any debris in there. See, we're clear of any debris. And this edge right here, this stainless edge needs to be as clean as possible. It'll leave little crusties and burnt up pieces beside your weld if you don't keep it clean. So anytime that you take off and do another weld, just rub it with a wire brush or a piece of material like this, just something to keep it clean.
If you have further questions on routing and welding, please refer to the EcoGrip installation manual for more information.